Hi viewers, you welcome back to class. This session still teaching bearings. Bearings are angles that are measured from north in a clockwise direction and are always written with three figures. This time around I have two questions to solve in this session. Let's read the question first. Given the bearing from A to B, calculate the bearing from B to A in each of the following. This is the first one, and we can see that the bearing from point A to B is 83 degrees. And the bearing from point A to point B can also be called the bearing of B from A. And in the question now, we are asked to calculate the bearing from B to A, which we can call the bearing of A from point B. The preposition from, it's a very important preposition in teaching bearing because you just have to understand the usage of the preposition in order to get it right and not to mess it up. So going straight to calculate the bearing from B to A. In my last video, I explained how we can get it right in two different ways, and I'll still do the same now. I'll draw the four cardinal points on point B now. The four cardinal points, we are the north, south, west, and east. What we are asked to calculate is the bearing from B. This is point B to A. We're going to move from north in a clockwise direction. So it will come this way to A. Okay? So this can be done in two ways. The first one is trying to use the co-interior angle C, which is the angle here. Using the co-interior angle C, it adds up to 180 degrees. So if these two angles add up to 180 degrees, it means to get the angle here, we're going to subtract 83 degrees from 180 degrees. And we have this co-interior angle C to be 97 degrees. It adds up to be 180 degrees. That has been established. So, now looking forward to calculate the bearing from B to A, which is what I've already mapped out here. Since the full turn at this point is 360 degree angle at the points, so it's easier for us to subtract 97 degrees from 360 degrees. 97 degrees from 360 degrees, it gives us 263 degrees. So the bearing from B to A will be 263 degrees. 263 degrees for the bearing from B to A, which we can also call the bearing of A from point B. That's the first way of solving it. The second method of solving it is when you are given a bearing and you are asked to find the opposite bearing. This is a bearing. The bearing from A to B has been given 83 degrees, and we are now asked to calculate the bearing from B to A. From B to A. So it's opposite to what we've been given. So to work out this in the opposite bearing method, when what we already got is now up to 180 degree, we're going to add 180 degree to this to get the opposite bearing. And if what we already got is over, that is, it's more than 180 degree, we subtract 180 degree from that bearing that has already been given. But in this case now, 83 degrees is less than 180 degrees. So what we do is to add 180 degrees to 83 degrees in order to get the opposite bearing, in order to get the bearing from B to A. I think I'm making points. Okay, so the bearing from B to A is equal to 263 degrees. Doing it through the co-interior angles method, we get 263. Do it in the way of opposite bearing, where we have 83 to be added to 180. 83 plus 180 degrees, we get 263 degrees. So it's still the same thing. The bearing from A to B is 83 degrees, and the bearing from B to A, which we can also call the bearing of A from point B. I think it's fine, viewers. I move to the second question. So viewers, let's look at the second question. The bearing from A to B is 325 degrees. The bearing from A to B. Now I want to calculate the bearing from B to A. So let's start by sketching the four cardinal points where we have the north here, south, west, east. And you know, in bearing, you move from north in a clockwise direction. So the bearing from B to A, let me just map it out. This is the bearing from B to A. That's what we are asked to calculate. The bearing from B to A. We've already been given the bearing from A to B. This is the bearing from A to B. This is the bearing from A to B. So the bearing from A to B can also be called the bearing of B from A. And this one we are asked to calculate, which is the bearing from B to A. The bearing from B to A can also be called the bearing of A from point B. I think I'm making sense here. The bearing from A to B has been given to us as 325 degrees. The bearing from A to B. And it can also be called the bearing of B from point A. And what we are asked to calculate is the bearing from B to A. The bearing from B to A, which we can call the bearing of A from point B. So I still want to do it in the two methods that I used for the first one, and which I've been using I used in my last video. I still want to do it that way. Let's look at 325 degrees here. For a full turn is at 360 degrees. So for us to get the co-interior angle C that is here, because this is the co-interior angle C, for us to get it, we're going to subtract 325 degrees from 360 and we are left with 35 degrees. So this is 35 degrees, but for bearings you have to write in a 3 figure. So it's 0, 3, 5 degrees. Now this co-interior angle C we add up to be 1/8 degrees. So if we are to establish that, and this place is 35 degrees and it's adding up to be 1/8 degrees with what we have here, it's going to be 35 degrees from 1/8 degrees, and we'll be left with 145 degrees as the bearing from B to A, or the bearing of A from point B. That's the first way. And the other way of solving it is the way of the opposite bearing. The initial one given to us is 325 degrees. So since what we have here is more than 1/8 degrees, we're going to subtract 180 degrees from 325 degrees to get the opposite bearing. You got what I mean? Since the initial bearing given is 325 degrees, and we are asked to find the opposite bearing, because in this case, when you got the bearing from A to B and you have to calculate the bearing from B to A, is our opposite bearing. So in this case, and what we add first is 325. It's more than 180, so to get the opposite bearing, we're going to subtract 180 degrees from 325 degrees. And in that case, we'll be left with 145 degrees. So in both ways, we still arrive at the same answer. The answer is the bearing from B to A is 145 degrees. And we can also say the bearing of A from point B. Thanks, viewer, for watching. Continue to like, share, and subscribe to my channel. Bye.